All right, let's take a look at limits. So what on earth is a limit? Let's take this as an example. Imagine you just had a graph that goes, it's a simple y equals x graph that goes like this, except for some reason, this one singular point is missing. Just imagine there is nothing in this one singular point and it's empty. You might be wondering, okay, but why does this one singular point at exactly 1, 1 missing? Well, there's no reason really, but for the math examiners and math teachers, they can write whatever equation they want. So if I wanted to just make this point missing for whatever reason, I could define this whole function as a compound function, like this, where from negative infinity to exactly the point 1, it is y equals x. And for the point from 1 to infinity, it is also y equals x. But hold on a second. This one doesn't include 1. This one doesn't include 1. So what the hell is happening at point 1? Nothing. It doesn't exist. So imagine it in this way. If I asked you what is f of 1, if you looked at this this function, you would say, I don't know, undefined. And that is true, because this point, according to this graph, does not exist. But let's look a bit closer. Notice how both sides of these equations are approaching one number that we can clearly guess. What is this one number? Obviously, it's 1, right? So surely x equals 1, y is also equal to 1, right? Well, yes, technically. So let's have a look at this. If f of 1 is undefined, then how can we tell someone that this point would actually be 1 if this point were to somehow exist? Well, we can write it as limit x approaching 1. So if you did limit x approaching 1 of f of x, you would get 1. Why? Because let's take a look closer at the graph again. From the positive side, which is this side, as you get closer to 1, what does the number get closer to? Like here it would be like at point 2 would be like 2, and then here would be 1.5, and then 1.25, and then da, all the way down, where if you go immensely, immensely close, you'll see that it will eventually get to 1. And it's the same thing with the other side. As you get closer and closer and closer and closer and closer and closer, it'll just almost right there be 1. So all that this equation is saying is that if I went infinitely close to 1 from both sides of x, eventually y will equal 1. Or it won't equal 1, but it will get so close to 1 that like it might as well be 1. So that is all that a limit is saying. Now, okay, you might be wondering, so why do we care? Can't we just use our eyeballs to look? Well, sometimes, but not always. Take this graph, for example. And I want to know, what is the y value at x equals 1? What is the y value? No idea. Let's sub it in and see. 1 take 1 on 1 squared plus 2 take 3. Hold on, 0 on 0? What does that mean? What does this equal? No one knows. It's undefined. So, okay, so that means there is no y value at x equals 1. Done, right? But if I was to draw this graph out for you, it would look something along the lines of, with an asymptote at both of these sides. We've got x equals -1 and y equals 0 as asymptotes, and the graph will look something like this. Now, have a look at this point. That is x equals 1. But hold on, this point doesn't exist. It's 0 on 0. So how come I feel like I can clearly see that this is a number here, right? Both sides are approaching something very closely, but they're never touching it. What this means is that as both sides approach this number, it is eventually going to get to basically some value of y. But we can't tell by just subbing in 1 because it doesn't exist, the point. So how do we solve it? Let's take a look at this. Limit x approaching 1 for the function again. Now, notice something about this function. It's actually a polynomial on the bottom. So what can we do with polynomials? We can factorize them. So let's do this a few more steps. 1 take x. So we all know how to factorize polynomials. X plus 3, x take 1. Now, let's go down again. What can we do to this? Well, we can't cancel it straight away, but we can, if you look at the top here, 1 take x, x take 1, that's only different by a factor of -1. So we get negative x take 1 on x plus 3, x take 1. So, okay, now we can cancel. So now we have limit x is approaching 1 of -1 on x plus 3, which then we can sub in x equals 1 and get -1 on 4. So this point that we're getting infinitely close to is y equals -1 quarter. So, okay, makes sense. Why do we need to write this weird notation? Well, technically this point doesn't exist. So all this notation is saying is that as we get infinitely close to x equals 1 from both sides, this side and this side, we'll eventually get extremely close to this number, but it won't equal this number. This number never ever gets touched. It just gets closer and closer to it. So that's the difference between simply x equals 1 and limit x approaching 1. Yeah. So, okay, with this knowledge, we can do some practice questions, which I'll show you in another video.